Good morning, students. Yes, chapter 3 current electricity continued. In last lecture we have discussed about Western bridge, one circuit, another meter bridge, application of Western bridge. Okay. Now, yes, in this lecture we will see our last theory, that is potentiometer. Yes, in potentiometer you have total 4 theories. First, what is requirement of potentiometer? Second, principle of potentiometer, and another 2 theory are uses of potentiometer. Okay, first of all we will see what is requirement of potentiometer. Okay, see. Requirement of potentiometer. For example, if I have a cell connected with voltmeter, okay, so if its EMF is E, current flowing is I, okay, then this voltmeter, it measures, this voltmeter measures terminal voltage, potential difference between two ends of cell. Okay, voltmeter measures potential difference between two ends of cell, or we can say terminal voltage, Okay, this voltmeter does not measure EMF. This voltmeter does not measure EMF. Okay, then how to measure EMF? See, if I write equation of terminal voltage, see here it is. If I write equation of terminal voltage, terminal voltage, V is equal to E minus IR. V is equal to E minus IR, where V is terminal voltage, E is EMF, I is current flowing from circuit, and R is internal resistance of cell. So yes, if you connect a cell with voltmeter measures potential difference between two ends of cell, or terminal voltage, it does not measure EMF. Then how to find EMF? See, if you observe this equation, V becomes E, means potential difference is equal to EMF. Potential difference is equal to EMF when IR is equal to 0. Yes or no? When IR is equal to 0. Now IR is equal to 0. When it is possible? When we have two conditions. I is equal to 0 or R is equal to 0. But internal resistance of cell 0, it is not possible. Each and every cell has some resistance. So yes, this internal resistance 0 is not possible. Okay, so what we will do? If I take I is equal to 0, then IR becomes 0, and if IR becomes 0, then V is equal to E. And when I is equal to 0, remember the theory of cell, EMF and internal resistance. Yes, when I is equal to 0, when I is equal to 0, it is called open circuit condition. When I is equal to 0 means open circuit condition. So in open circuit condition, we can write V is equal to E. Whatever potential difference this voltmeter measures is equal to EMF. So yes, you have to remember this concept. When I is equal to 0, V is equal to E. Potential difference is equal to EMF of cell. And yes, potentiometer is a device in which we can achieve open circuit condition and we can measure EMF. Okay, yes, what is potentiometer? Potentiometer is a device. Potentiometer is a device in which we can achieve open circuit condition. And we can measure EMF. Clear about this? So yes, what is potentiometer and why it is required? So it is requirement of potentiometer. Again, if you have a cell, you connect voltmeter with it. Voltmeter measures terminal voltage, not EMF. When terminal voltage is equal to EMF, when IR is equal to 0. IR is equal to 0 means two probabilities. I is equal to 0 or R is equal to 0. Internal resistance 0, not possible. So yes, if I achieve I is equal to 0 in circuit, means if I can make open circuit condition, then in open circuit condition V is equal to E. Terminal voltage is equal to EMF. Terminal voltage is equal to EMF. So yes, potentiometer is such a device in which we can achieve open circuit condition and we can measure EMF. Clear about this? So yes, it is your first theory. What is requirement of potentiometer? Now next one is principle of potentiometer. See, what is principle of potentiometer? For better understanding of principle of potentiometer, we will consider one circuit. See, what is circuit? Okay, here is a cell of EMF E. Its internal resistance R. A key resistance box RB. Each and every element are connected in series with a potentiometer wire AB. Like this. It is potentiometer wire AB. Potentiometer wire. Clear about this? Again, see what is circuit. A cell of EMF E. Its internal resistance are key means switch, resistance box, potentiometer wire AB. These all elements are connected in series. They are connected in series. So clear about this each and every term. E, R, K resistance box and it is potentiometer wire AB. Clear about this? Okay. Now see, for this resistance, for this potentiometer wire, this wire AB is called potentiometer wire. For this, how to write? See. Okay, see, length of potentiometer wire is L. I am assuming length of potentiometer wire is L, capital L. Okay, length of potentiometer wire is capital L. This length A to B, this length is capital L. Okay. Also, let resistance per unit length of wire is rho. A is rho. Clear about this? Length of potentiometer wire is L. Let resistance per unit length of wire is rho. And see, this wire is of uniform cross section. So yes, we can take this resistance per unit length of wire rho as constant. Okay, so length of potentiometer wire is L. Let resistance per unit length of wire is rho. Then what is resistance of this potentiometer wire? See, therefore resistance of potentiometer wire, yes, I can write PM wire. Okay, resistance of potentiometer wire is equal to L rho. Clear about this? Length is rho, resistance per unit length is rho. Okay, so resistance of per PM wire, potentiometer wire is L. Clear about this? Okay. Now, see. Let from positive terminal of cell, current flowing is I. Yes, it is in series connection. So current flowing is I. Current flowing is I. Clear about this? Then according to Ohm's law, how to write current flowing from circuit? How to write current flowing from circuit? See, current flowing from circuit. Current flowing from circuit. How to write? See, here it is. I is equal to EMF upon total resistance. EMF upon total resistance. Now, what is total resistance in this circuit? See here. Cell. Its internal resistance is R. Resistance box. Its resistance is R. See, this resistance box is to control current. This resistance box is used to control current. Okay. Yes, it is resistance box. And another is resistance of this potentiometer wire. Then how to write total resistance? See. What is resistance of resistance box? R. Plus resistance of this potentiometer wire, it is L. Plus resistance of cell, yes, here it is R. Clear about this equation? Current flowing from circuit, I is equal to E upon R plus L rho plus R. Where what is R? Resistance of resistance box. L rho, resistance of potentiometer wire. And small r, internal resistance. Yes, each and every element they are in series connection. So total resistance is R plus L rho plus R. Clear about this? And yes, current flowing from them is same. Okay, so yes, it is equation of I. Clear about this? Clear about this? It is equation of I. Okay, current flowing from this wire is I. Now, I am taking 2 points on potentiometer wire. I am taking 2 points on potentiometer wire. For example, points are, it is A, and let here it is C1. And let this length is L1. Clear about this? Okay, so chalo. How to write? Okay, take a part of potentiometer wire. Potentiometer wire having length AC1 is equal to L1. Clear about this? Now see, AC1, it is a part of wire. Current flowing from it is I. It has some resistance. Yes, it has some resistance. Yes, it is wire, then wire having some resistance. What is resistance of this AC1 length? Okay, resistance of length L1 is rho L1. Clear about this? What is resistance of this part? Its length is L1 and resistance per unit length is rho. Then its resistance is rho L1. Current flowing from it is I. Current is I. Resistance is this. And what is potential difference between AC1? Potential difference between A and C1 means VAC1 means VL1 is equal to what is current I, what is resistance rho L1. Clear about this? Now put value of I is equal to it is E upon R plus L rho plus R. Okay, and here it is rho L1. Clear about this? Okay, yes, it is easy. Yes, it is easy. Okay, take a part of potentiometer wire AC1 is equal to L1. Resistance of length L1 means resistance of this wire is rho L1. Potential difference between A and C1, VAC1 is equal to VL1 is equal to I rho L1 is equal to E rho L1 R plus L rho plus R. Now if I am taking another part, see, if I am taking another part like this, A to C2, and this whole length, suppose this whole length is L2. Clear about this? Okay, then yes, you have to take another part. Take a part of potentiometer wire AC2 is equal to L2. Then what is its resistance? Yes, its resistance we can write directly. It is rho L2. Clear about this? Rho L2 like this. So what is potential difference between A and C1? Potential difference between A and C2. How to write? See, VAC2 is equal to VL2 because between A and C2 that is L2. So how to write it is? It is I rho L2 and is equal to, I can write if you put value of I, E rho L2 upon R plus L rho plus R. Clear about this? Then see, first of all I have L1 length of wire, then it is VL1 is equal to E rho L1 upon R plus L rho plus R. Clear? Now I have L2 length of wire, then what is equation of potential difference VL2? E rho L2 upon R plus L rho plus R. Now if you observe these two equations, if I change length of wire, then E rho R plus L rho plus R, it is same, only this length is changed. So we can say from these two equations, potential difference between any two points depends on distance between 2 points, is directly proportional to distance between 2 points. I can write it as VL is proportional to L. VL is proportional to L. The potential difference between 2 points is directly proportional to length of that part. Okay, VL1, here I can say VL1 is proportional to L1, here I can say VL2 is proportional to L2. So in general, how to write? In general, I can write VL is proportional to L. Potential difference between 2 points is directly proportional to distance between 2 points or length between 2 points. Clear? And it is called principle of potentiometer. Okay. Okay, see, VL1 is equal to E rho L1 upon R plus L rho plus R. VL2 is equal to E rho L2 upon R plus L rho plus R. Okay, so yes, how to write this equation? See this term E rho R plus L rho plus R, in both equations it is common. So I can replace this as VL is equal to sigma L. VL is equal to sigma L, where this sigma is called potential gradient. See, if I write like this, VL is proportional to L. VL is proportional to L. It is principle of potentiometer wire. The potential difference between 2 points. Is directly proportional to length of that part. VL is proportional to L. And if I say VL upon L, then is equal to, it is sigma. And this VL upon L is equal to sigma is called potential gradient. And you have to remember this. Okay, VL upon L is equal to sigma is called potential gradient. VL upon L is equal to sigma is called potential gradient. And see, this potential gradient will remain same. What is value of potential gradient? Sigma is equal to E rho upon R plus L rho plus R. Yes, you have to remember this. Okay, what is value of this sigma? Sigma is equal to E rho upon R plus L rho plus R. Okay, so yes, it is principle of potentiometer wire. VL is proportional to L, or you can write VL is equal to sigma L. Now we will combine two conditions. Okay, we will combine two conditions. See, in open circuit condition, means when I is equal to 0. Means when I is equal to 0, we have proved that V is equal to E. Yes or no? Yes it is. Yes it is. And what is principle of potentiometer wire? What is principle of potentiometer? What is principle of potentiometer? Principle of potentiometer is V is equal to sigma. So if you combine these two, conditions, then we can write V is equal to E is equal to, it is sigma. Okay? Okay, and now with the help of this, we will see its applications or uses of potentiometer. Uses of potentiometer. See, uses of potentiometer. Uses of potentiometer. Uses of potentiometer. First use is to compare EMFs of two cells. To compare EMF of two cells. What is circuit? See, here it is. Cell, internal resistance, key, here is your state. A, potentiometer wire. Okay, like this. It is EMF E. Cell. Its internal resistance R. A key. It is rheostat RS. Or you can say it is resistance box. Having resistance R. Potentiometer wire. It is A. Potentiometer wire. It is A. Yes, you know this circuit. Yes, you know this circuit. Now, to compare EMFs of two cells. How to connect two cells? See how to connect two cells. From this point A, first take one wire, connect one cell. Okay, from the same point, take another wire, another cell. Clear about this? It's EMF E1, it's EMF E2. So, both cells, there one terminal, positive terminal is connected to point A. Another terminal, C, here. It is a key. It is also a key. Let it is key K1, it is key K2. Clear about this? E1, key K1, E2, key K2. And from this connection common to both points, okay, you have to connect one galvanometer G with a job. Clear about this circuit? Okay, yes, you know what is this potentiometer circuit? To compare EMF of two cells, it is additional circuit. Okay, two terminals, positive terminals of cell are connected with point A. Two negative terminals are connected with galvanometer and jockey, but there is place of key. Clear about this circuit? Okay? Now, yes, you have to remember one important point about this. If you want to compare this to EMF E1 and E2, then it is called driver cell. E should be greater than E1 and E. Okay, E greater than E1, E greater than E2. Clear about this? Okay. Now what is method? How to perform experiment? Initially, these two keys are open. See, this key is closed. So now current flows from circuit. Okay. Now if at first point, I close this key. Means key K1 is closed and K2 is open. Then see what happens. Current is flowing from this cell. Okay, so if you make contact of this jockey with this potentiometer wire, like this. If this jockey you move on this potentiometer wire, this galvanometer will show some deflection, means it will show some current. Clear about this? Again, if you close key K1, okay, this cell E1 comes in circuit. Galvanometer shows some deflection when you move jockey on this wire. Clear about this? Okay, so see how to write. Here it is. First condition, yes, when key K1 is closed and K2 is open. And K2 is open. In this condition, what happens? Yes, this E1 cell comes in circuit. Okay, you have to move this jockey from this point A. Yes, this galvanometer will show some current. What you have to achieve? You have to achieve open circuit condition. Means when current flowing becomes zero. When current flowing becomes zero, then what you have to do? You are moving jockey. You have to observe galvanometer. Let at this point C1. Okay, this galvanometer shows current zero. Means yes, this C1 is called null point. Okay, so K1 is closed, K2 is open. In this situation, you have to move jockey on potentiometer wire. And then you have to find null point. Null point means where current I is equal to 0. Suppose at point C1, current is 0, then you have to measure its length. That its length is L1. Okay, let AC1 is equal to, it is L1. Clear about this? AC1 is equal to L1. Clear about this? Then what is potential difference between two ends of A and C1? V is equal to, yes, this EMF, this cell is in connection. So yes, we can write V is equal to E1 and is equal to sigma L1 with the help of this condition. Yes, here K1 switch is closed, so this cell comes in circuit. So we can write potential difference between two ends B and C1 is equal to EMF of this cell, and is equal to sigma L1. Clear about this? So it is your equation number 1. Now you have to repeat experiment. How? In second case, K1 is open. Okay, let it is open. K1 is open. Okay, it is open now. And now you have to close K2. Then yes, K1 open and K2 is closed. Again, repeat your experiment. Move this jockey on potentiometer wire, and find a null point. Suppose here it is C2, it is null point. Here it is C2, it is null point. Okay, so yes, here you have to again write move jockey on potentiometer wire. Let null point is C2. And AC2 is equal to L2. Then how to write? V is equal to potential difference between two ends. Of this wire AC2 is equal to, now which cell is in connection? Yes, this cell having EMF E2. Then how to write? V is equal to E2 is equal to sigma L2. Clear? Okay, if you take ratio of these two equations, then E1 upon E2 is equal to sigma L1 upon sigma L2. E1 upon E2 is equal to sigma L1 upon sigma L2. Sigma, yes, sigma is constant. E rho upon R plus L rho plus R. Yes, we know it. So sigma cut, then what remains? E1 upon E2 is equal to L1 upon L2. Okay, and with the help of this equation, you can compare EMF of two cells. Okay, see, method is easy. Circuit of potentiometer, two cells you have to connect. When you connect or when you close switch K1, you have to find length where we achieve null point. It is L1. Next time you have to close this switch and measure another null point. Its length is L2. So yes, you have to measure L1 and L2. You have to measure L1 and L2. So what is the equation? E1 upon E2 is equal to L1 upon L2. So yes, with the help of this, you can compare two EMFs. Also, see, from these two cells, if I have one known cell, for example, I know what is EMF of this cell, then I can easily find EMF of this cell. Clear? So yes, this potentiometer wire is used to compare EMF of two cells, or also to find EMF of a cell. You have to remember these equations and what is value of sigma. Okay, so it is use of potentiometer. Now second use is to determine internal resistance of cell. How to determine internal resistance of cell? See, this circuit is common. Okay, yes, it is a cell having some EMF, having some internal resistance. Key. Yes, we can also say this one battery. It is one battery that is used in laboratory. Okay, so yes. Now, what is circuit change? From this point A, let it is one cell having EMF E and its internal resistance R. It is connected in parallel with a resistance box. Okay, having resistance R and a key. And from this point, yes, again, one galvanometer is connected, and here is one jockey. It is TK2. Clear about this? So yes, it is circuit to find internal resistance of cell. Now what you have to do? See, this TK2, first of all, kept it open. Okay, so yes, here I will write. In first case, this TK2 is open. It is not closed. Yes, it is open. When switch is open, when T is open, it offers infinite resistance. And therefore current is not flowing from it. So yes, when this switch K2 is open, current is not flowing from this. Means current is flowing from this cell towards this galvanometer, this jockey. And if you make contact of this jockey with this point A, means on this wire, this galvanometer will show some deflection. Okay, so now what you have to do? Again, as it is application of potentiometer wire, you have to achieve open circuit condition. Means you have to find null point where current becomes 0, and at that point you have to apply principle, that is V is equal to sigma L1. Okay, how? When K2 is open, yes, this cell is in connection. And during this condition, you have to move jockey on this potentiometer wire, until you find null point. Let I am moving jockey, and at point this point C1, I found, okay, when K2 is open at point C1, galvanometer shows 0 current, means it is null point, So yes, in this situation, open circuit condition is achieved. So in this condition, potential difference between point AC1 is equal to VAC1 is equal to EMF of this cell and is equal to sigma L1 that we have discussed in principle. Clear about this? So VAC1 is equal to E is equal to sigma L1. Clear? Or how to remember? L1 is when K2 is open. L1 is null point length when K2 is open. Now, in second case, you have to close K2 when K2 is closed. So yes, now current is flowing from this resistance. Clear about this? Repeat your method. Take this jockey, move this jockey on potentiometer wire, find another null point, let it is C2. Okay, so when K2 is closed at point C2, you find null point. You find null point. Okay, means current I is equal to 0. Then in situation VAC2 is equal to, now see, it is resistance, and between two ends of resistance we have potential difference, not EMF. Again, it is battery. So when current flowing from cell is 0, we know that potential difference between two ends of cell is equal to EMF. Yes, we know it. But it is resistance, and between two ends of resistance we have potential difference. So I will write it as V. And yes, this V is equal to, it is sigma L2. It is sigma L2. Clear about this? Show how to write. When key is open, null point L1. When key is closed, null point L2. Okay, now take the ratio. Means E upon V is equal to sigma L1 upon sigma L2. Clear about this? Sigma cut. So E upon V is equal to, it is L1 upon L2. Okay. Now E means EMF. If you apply Ohm's Kirchhoff's law, then E will be get. It is E means E is equal to, it is I R plus R. E is equal to, it is I R plus R. And what about this V? It is potential difference between two ends of resistance. It is potential difference between two ends of resistance. So yes, I will write it is I R. Clear? Is equal to, it is L1 upon L2. So yes, it is L1 upon L2. This I cut. Okay. Now if you simplify this, then R upon R, it will become 1. Plus here it is R upon R. Clear? Is equal to, it is L1 upon L2. So R upon R is equal to L1 upon L2 minus 1. Clear? Okay. So R is equal to, it is R L1 upon L2 minus 1. And yes, it is equation of internal resistance. R is equal to R L1 upon L2 minus 1. Now what is L1 and L2? Simple. See, this R is value of this resistance box. Value of this resistance box. L1 is length of null point when switch is open, and L2 is length of null point when switch is closed. So yes, you have to remember this equation to find internal resistance of cell. Clear about this? So it is all about uses of potentiometer. First use to compare EMF of cells, and second use to determine internal resistance of cell. You have to remember this equation. Okay.